I feel like I've seen something very similar before, I just can't remember where. But is it good as that one? Hello, welcome to my tech farm, to another filament dryer review video. This is Elegoo H1 HT. And the reason why Elegoo sent me this product for the testing are commenters and users who wrote directly to Elegoo that before the buying they want to see my tech farm test first. Huge thanks for this, and yes, I have my regular testing method, that sponge drying test, and with this the results are comparable with those which I did in earlier videos. I got these products for free, but there is no additional payment from side of the Elegoo, but this video and actually the whole channel is sponsored by Polymaker. I also got two spools, one TPU and PETG, but out of the box probably these are dried filaments. Maybe I will check if I have some older PETG to present before and after drying, but the most important part of this video is actually sponge drying test. Let's see some specifications from the website. The maximal temperature 85 degrees Celsius, rotating the spool for more even drying, automatic moisture ventilation, easy control with 11 preset materials, lid open detection, interesting feature, and one very important feature for me, 38 decibels, the noise, and I will measure this. One of the main reasons why I like to use the HTMS that it is quiet. And another important information, now the maximum power is different for 110 and 220 volt areas. In Europe it's 220 or 230, and they measure for 85 degrees Celsius 8 hours. It will consume 0.386 kilowatt hours, and in my country this is approximately $0.06, so this is really not expensive drying. And now the most important advantage versus HTMS, it says no brand lock-in. This means it is independent from the brands. We are not locked into the Elegoo ecosystem or something like that, and I think it can even work independently, but I will check this later. And which filament are more sensitive to moisture, TPU, PETG, PA or nylon, but almost every carbon or glass fiber reinforced filament is more sensitive to moisture than regular one. And we will get a nicer surface if the filament is dried, no stringing. This is typical for the PETG. If it is wet, we'll have a lot of stringing, no over extrusion, because those micro water drops will boil inside the nozzle and push out more material, and with this we will have a very ugly surface, and usually it is even bigger. We can measure this with the caliper, and because of this we will have a weaker layer adhesion, because don't forget, stringing is oozing from the nozzle when it's moving from one location to other. So that material should be part of the real object, and if it is in a string, the real object will be weaker. And we can see this first on the layer adhesion, but other properties will be weaker too. They also measured how long we can store the filament inside, if it is 65% relative humidity, 25 degrees Celsius environment, and it is 10 days. And actually I noticed that the HT-AMS is quite weak in this, and actually other commenters confirm this. The AMS2 Pro is much better for this. Maybe in a separate video I should measure how long we can store the filaments to measure the change in the relative humidity inside, but subjects for separate video. Let's see what's in the box. Let's start unboxing the filament first. This is PETG Pro, and we have the drying temperature 65 degrees Celsius for 8 hours. And this is TPU 95A, so it is moderately soft. And also we have the drying temperature 70 degrees Celsius for 8 hours. Already mentioned, if they are dried before this good packaging, they will be dried out of the box, so I will use some other filaments for this presentation. And actually I like their PETG filaments because they will not become brittle by time, and they will not break inside those multicolor systems. A little bit off topic, but it would be great if I could finally test this somehow, because I noticed that some brands, or at least types inside the brand, will break inside that AMS or similar multicolor units, and some of them not. For example, Bamboo Lab PLA Basic is good, it will not break inside, but the tough version, the old one, yes, after a few days, and maybe that's the reason why it is discontinued and replaced with the Tough Plus. Filament Polymaker PETG is also good, Elegoo already mentioned, Snapmaker also good filament, but for example Form Futura or Esun PL Plus, they are brittle and they will break inside these units even after one day. So what is your opinion? Should I test this somehow? Now let's continue with the unboxing of the dryer. This was content of the box, the main unit, user manual, power cable, Teflon tubes. This locking mechanism is a little bit weird. I thought I have to press it down, but I have to lift it, only I have to support with my other finger, and now it's opened. I'm not sure is it visible on the screen too, but this is the space for the desiccant. This was included in the package. The desiccant will not help with the drying, but it will help with the storing of the filament. And that's the opening for the ventilation, and here we can see it on the other side. We have two exits of the filament, the top one for the TPU and carbon fiber filaments, very similar to the HT and the bottom one, but first I have to insert this pneumatic fitting. And here goes the Teflon tube. Turning on to check the screen. Selecting the language properly on the first time starting. The screen almost reminds me to some printer. Here we can set the temperature, the drying time, but we have some preset values too. For example, for the polycarbonate it is 80 degrees Celsius, 8 hours. Rotating during the drying, lid open detection, actually I don't really need this. And some other settings, Fahrenheit or Celsius, language and similar. Just to be sure that it can work completely independently, now it is not connected to any printer, I inserted a spool of PLA, start, warning to lock end of the filament, and start. It is hard to see inside, but I think it is rotating the spool very slowly. Aha, now I could hear the ventilation hole. I think I have to create some time lapse to prove that rotating of the spool. Actually, this spool is stuck inside, and soon you will see why. I place a smaller one, and I could see that it rotates the spool for 1 minute, and it starts every 5 minutes, and during this it will be rotated approximately 60 degrees. Now I tried several spools, and I noticed when I tried this spool, few times it stuck and didn't want to rotate. The diameter is okay, and the thickness is approximately 68 millimeters, which is on the upper edge. But the problem is this, I hope you can see it, the spool dimension is on the upper edge of the maximal dimension, and any damage or deformation will make it stuck, so be careful with this. So far my experience is very positive. It is also very quiet, even now it is drying, only I'm outside currently, later I will measure the noise from the inside. This maximal spool thickness could be a little bit bigger, it's on the edge of the acceptable. And now I will start my sponge drying test, and if the drying performance will be very similar to the HTEMS, in that case this may become my new favorite filament dryer, because it can work completely independent from the brand or from the printer. This is the HT22 humidity and temperature sensor, and the position of the sponge will be approximately in the center, and position of the sensor will be approximately 60 millimeters above the input hot air. The data I'm collecting with Arduino Uno, and on the screen I can see the current temperature and relative humidity, but on this laptop I'm collecting the data every 10 seconds. Weight of the empty sponge 0.570. .593. Setting the temperature to 85 degrees Celsius and starting the stopwatch. After approximately 3.5 minutes, I could hear the opening of the ventilation valve. And according to its own sensor, it is almost 85 degrees Celsius. According to mine, 62 so far. Interesting to see that the temperature dropped down to 70 degrees Celsius. Now it is increasing again. Maybe that was the ventilation valve opening. After 20 minutes, the temperature inside is 78 degrees Celsius according to my sensor and 13% relative humidity. According to there, it is very close to 85, 84 and 10% relative humidity. It's time for half-hour measuring. 0.552, drier than before because it had some moisture from the environment. quick view with the thermal camera, and I can see or feel with my finger that the heat leaks out, so it could use a little bit better thermal insulation. Let's see it from the back side. And this is the left side, but at least it is completely safe for the touch. Now I can even feel the hot air through this hole, and you can see it on my finger too. I didn't pay attention how long is this open, but I can feel this now 2 minutes at least. And big question is, why is this open if the relative humidity inside is approximately 10%? I mean, so low relative humidity, this shouldn't be opened because we are losing heat. Maybe this ventilation is not only to let out the moisture, but also with this it stabilizes its own temperature, because according to its own sensor it is 85 degrees Celsius stabilized. And soon it will be time for the 1 hour measuring. This is completely dry. 0.532. It cannot be drier. It's hard to see inside because it's quite dark, but now I move the sensor. It is exactly above the input hot air. Let's measure this temperature, and this is more important size. This dryer rotates the spool during the drying. The temperature stabilized around 86-87 degrees Celsius. The peak was 89, but for these high temperatures, that's okay. Of course, according to its own sensor, it is 85 degrees Celsius. Now I'll turn it off and collect some cooling data. The temperature cooled down to 54 degrees Celsius, and it's time to collect the data. It's time to analyze the results. This is the time in minutes, and here we can see the temperature and relative humidity. Let's start with the temperature. Very quickly it reached 85 degrees Celsius according to its own sensor. That's why it started turning on and off the heater. It has approximately 80 seconds cycle. And here it is open for 30-minute measuring, here for 1 hour measuring. And I moved the sensor to be exactly above the input hot air, and this is some cooling data. We can see the maximum was 78 degrees Celsius, when my sensor was approximately 50-60 millimeters above the input hot air, and when I moved that sensor to be exactly above the input hot air opening, in that case the peak was 89, but the average was approximately 87 degrees Celsius, which is great, very close to set temperature. Let's talk about relative humidity. Remember, I mentioned approximately at 3.5 minutes I recorded that the ventilation valve was open, and we can clearly see its effect. Significantly the relative humidity dropped down, and basically here I cannot even recognize this cycle or where it was opened again. Here it was open for 30-minute measuring, but no significant change because most of the moisture was already let out. And here it was opened for 1 hour measuring. Actually, I have more cooling data, only I forgot to extend the graph. And I'm always collecting this information, but I never used it before. Let's try to compare this to some similar dryer. With the orange, we can see the H1 HT, and with the blue, the EMS HT. And we can see even if it started from the lower temperature, after approximately 4 minutes, the temperature inside EMS HT was a little bit higher compared to H1 HT. This means the thermal insulation on EMS HT is a little bit better, and this is something what I could see on the thermal camera too. The sponge drying tests don't have too much sense on this temperature, only basically the collected data is more important for me. After 30 minutes it was completely dried, even drier than the beginning because it had some moisture from the environment, and even more drier was after 1 hour. It is so quiet that for this measuring I have to wait to finish the experiment and turn off the laptop because it is louder than the dryer. (33-34 decibels), that's super quiet. Overall, I really like this dryer. 85 degrees Celsius, super quiet. It can rotate the spool during the drying. Only you have to pay attention that the spool thickness is below 68 millimeters. And I checked other polymaker spools. Usually they are below 68 millimeters, and looks like accidentally I find one which is on the edge with a small deformation, it's stuck inside. And I think the only advantage of the HTMS is if you are using it with the bamboo printer and they can communicate with each other. But if you need an independent filament dryer, this is a great product. And in the near future, I want to compare several dryers to measure their storing capability. I have the same sensors and I will insert them into these dryers and to measure the change in relative humidity after, let's say, 1 week. And I hope you will follow me to that video too. Until then, thank you for watching this video till the end, and as always, happy drying and printing.